Morning, good afternoon, and good evening, everyone. Thanks for joining us for another Data Engineers Lunch. We are now on Data Engineers Lunch 92. We are thinking of doing something special maybe for Data Engineers Lunch 100. That's still in the works, but we're glad everybody's able to join us and start the week with us today. This afternoon, we have Nick delivering the second part of his Deploying Google Managed Instance Groups with Terraform series. The organizers for this event are Raul and myself. We are looking for speakers and sponsors for this event, so if you're interested in either opportunity, please reach out to me at the email listed below. We are part of a larger community called Data Community DC, which believes in building an inclusive environment, so no matter your race, gender, or sexual orientation, everyone is welcome, and we respect to be given to all. Data Community DC is made up of a lot of different groups, generally surrounding data. You can find out more about these groups at the links listed below. So what do we cover here at our Data Engineers Lunch? If it's your first time here, we cover everything from the ingress and egress of data and everything in between. We cover everything from databases, ETL, data wrangling, and all the tools and processes in the data engineering world. If it's your first time here on Data Engineers Lunch, please introduce yourself in the comments, how you work with data, how you found out about this lunch, and perhaps what you're hoping to learn from this lunch, and maybe we can incorporate that into future lunches down the line. Group rules: if you have a question, ask it. We want this to be a community. We want everybody involved in our lunches. Like I mentioned earlier, please be polite and courteous to others and share what you know with us. Here at Anant, we design, build, and manage global real-time data and an analytics platform surrounding Cassandra, Spark, and Kafka. We'd like to thank our program sponsors, our organizational sponsors listed below. And very quickly, if you have any 15-second announcements, any jobs, meetups, hackathons, conferences, classes, or other lunches, please leave the information in the comments below, along with a link for everyone joined. Data events, we have our Data Engineers Lunch every Monday, as you know, and then we have our Cassandra Lunch every Thursday at noon as well. Please make sure you're subscribed to our Meetup channel and our YouTube's channel as well, so if we go live, you're notified about that. And then finally, our latest runbook did come out last week. This edition is focused on using Terraform and Ansible to install Cassandra on AWS and Azure. Our runbooks are free. At least this particular runbook is free. I'll be leaving the link in the comments below so you could download that. And with that, I'll be handing it over to our speaker for this afternoon, Nick. Nick, over to you.
Thanks, Akwi. And just one of the things Akwi mentioned is questions. My question policy is, if you have it, please ask it. You're definitely not the only person wondering about the thing, and I'm always happy to provide clarification in context. I think, for me, that makes more sense than sort of waiting to a natural stopping point. All right, so let's dive in. This is the second session where I've been discussing managed instance groups with Terraform. So let's start with sort of where we finished last time. Last time we talked about how managed instance groups give you some of the features of Kubernetes with less complexity. And we went through instance templates, machine images, and images in GCP. And we talked about using this custom image as the primary resource for managed instance groups. We went a little deeper and talked about some of the resources that are available, how Google has a container registry, which is this marketplace of phenomenal number of containers from basically all of the major software providers, everything from Airflow to Kafka to Spark to deep learning. I don't think OpenAI has a container on their marketplace yet, but I would be shocked if that wasn't coming soon. We talked about the artifact registry versus the container registry. Google is moving into sort of trying to deprecate their container registry to this more general artifact registry, which, again, you can use existing artifacts that great open source providers have given to us. You can buy images on Google's marketplace as well, Or as I did last week or last time, we can build images for ourselves, containers for ourselves, and host them in the container registry or the artifact registry. We talked about these benefits. We talked about essentially the ability to self-heal and auto-scale as two of the main benefits here. We talked about sort of inbuilt load balancers, and then we talked about how to turn off the load balancer if you have an application like Cassandra. And we did a demo where we deployed a regional managed instance group and essentially saw that it had the image on there that we wanted it to have. But as all of us know, software isn't static. Systems are not static. And one of the core principles of Anant's playbook is that tools need to be extensible. We need to plan for whatever the next version is. We're going to dive a little bit deeper into that today, a little deeper into what updates look like with this tool set, and we'll go forward from there. So these are some of the details that we discussed last time. If you want to go review the video, it's on our channel at, you're watching on the channel here, youtube.com/AnantCorp. So let's dive in and just get a little reminder about how this works. So let's look at the code from last time. So, that is the wrong one. So this is now up. The code from last time is now up on our GitHub, github.com/Anant. And let's take a look at the first DEL code. We indicated that the provider that we were using is Google. If you want to deploy onto multiple clouds, you need to use a Terraform property called aliases. We defined the backend, which in this case was a GCS bucket called DEL MIG Terraform backend. The name isn't really important here, but the importance is where this bucket was located. Okay. And we defined this resource template, which was pulling this image, and this image is really one of the key things here. And we define a default network interface, and this is one of the core components. We defined some properties that we wanted to go into the service account. And notice if you try to pull this code directly, you'll need to figure out what your service account is for the particular project that you're working in. This will be a string of about 15 numbers. And then we defined the instance group itself. Okay, this instance group manager is the thing that's telling us how many nodes we have, where they're going to be deployed, and what the instance template is that we're going to be using to deploy this code, to deploy these VMs. And this is the instance that is above. So this Google Compute Instance template, that's referring to this resource. We're giving the specific resource name if we want to deploy multiple templates, which we did not in DEL 90, but we will in DEL 91. And then this is just indicating that, it's referring to itself. This is the last resource, which is relatively important. This is telling us the number of instances that will be deployed with this template. So these are the basics here. And let's see what it looks like when we go to deploy these. So I'm in my Google Cloud Shell. The benefits of doing this in Google Cloud Shell is it handles some of the authentication. I also worked on this demo using a Bastion VM, where I essentially deployed a VM, installed and initialized Terraform, and it worked relatively well. But there were occasional conflicts with Terraform, and I went to some of the recommendations, I reviewed some of the documentation, and Cloud Shell is just so well integrated into GCP that you can sort of get a lot of benefits here. So in just a moment, we'll take a look at the changes that I made for the next set of code. But for now, let's just remember sort of how this basic deployment goes. So we first, as with any Terraform deployment, we have to initialize the backend. And I actually ran into a conflict when I went for Terraform init, which we'll get into here in a minute. Let's go and confirm what resources currently exist. Okay. Currently, the only VM that is deployed on this project is this DELMIG2 VM. And I'd recommend having one VM, which this is sort of the VM from which you're building your instances or your images, excuse me. So we have this instance, we're going to use it to build images, and we'll take a look at what some of those images are. Currently, no instance group up. No instance templates have been created. That's something we did with Terraform last time, and we'll do with Terraform again this time. This time, we actually have more images, and we'll get into why that is. But part of the benefit of managed instance groups is they handle updates to your group, to your VMs very well. And we'll take a look a little later on at how to update the image that your instances are using. You can tell from the size here that each of these instances has had a few more dependencies installed. This first image was essentially bare. It had nothing. This 800 megabyte image, this had literally just a apt-get install or apt-get update run on it. And then I started installing some useful packages like Python in image 3. And, as an architect, right, I look at this and I see this in a couple of ways. And I'll see our ability to, this is version control, right? We can get really specific about what image we want to run on our templates. And, this is also going to be useful if we need to roll back updates that we make. If we find out that the image that we deployed broke something that was working previously, we can easily roll back to previous images. So we just also a reminder, you do have to initialize some IAM features in order to get Terraform and this managed instance group to work. Okay. The compute image user, this one's really essential, as is compute instance admin. These are essentially allowing you to make images. These storage objects right here, these are letting us initialize our Terraform, our remote backend on GCS. And just generally, there's a multitude of talks that you could have with IAM, but one of the key things you'll pull from here is you'll pull this service account ID from your IAM. And if you recall, that was stored in the, this is actually in the instance template resource block. All right. So I have this bucket as well, which was the backend that we defined. So I've initialized Terraform. Let's do a Terraform plan to see if we expect anything to break and see what changes we expect to happen. You'll notice that this is sort of the thing that is the summary, right? There's nothing that's getting destroyed if I were to run a Terraform apply for this. Nothing that's getting changed. And that's because, as I showed you, we do not have a managed instance group up. There are no instance templates that have been built here. So if you're following along really closely from last time, you'll notice that we do have 2 more resources involved in this deployment. And we'll talk about what those are in a moment. We still have the target size set to 2. We have the same base instance name, and we have this instance group manager, and we have these this template. Notice there's a template 2 here. We also have this template, which does not have the 2. And then we have this new resource, which is the auto healing resource. Or excuse me, this isn't the auto healing resource. This is the compute health check resource. This auto healing is its name. So this all looks good. Let's try a Terraform validate to see if there are any expected conflicts that Terraform plan didn't pick up. Nope, looks like we're good. And now let's run our Terraform apply. And auto approve this so I don't have to type yes. All right, so we now have these resources that are starting to get built. This is essentially where we were last time with a couple of extra resources. Let's take a look at what those are. So when we refresh here, these might have come up already. They might not have, but we'll eventually see 2 new, oh, yep, they're not up yet. Taking a little time. I suspect this managed instance group, this will probably be the first thing that comes up. And as you can see, we now have, this managed instance group is here. And if you look in my code, you can see this name DEL make manager. Oops, that's not where I want to be. This DEL make manager is coming from the actual name of the instance group that I created in Terraform. So this DEL make manager, that is the name that I gave it. And Terraform is sort of creating these resources for me. So the new resources that are here is we have this health check. This health check, again, is named auto healing. And some of the values that I initialized for this, this is a number of seconds between which it will do these health checks. It's going to essentially be looking through port 8080. In this, there are a couple methods here. We'll get into these in a moment, but this is using essentially an HTTP health check. It's using, this port and this path to ping the VM and see if it's working and see if it's healthy. This is one of the things that I changed. I changed this unhealthy threshold to sort of make it happen a little faster. The default here is 50 seconds. And then this came along with this auto healing policy, which I added into the Google Compute Region Instance Group Manager. So let's see if our resources have spun up based on, yep, what's happening over here. Our resources should be up. So we have 2 new VMs that have spun up. We have this 0 LRM and this 7HX2 machine, both of which spun up when we did our Terraform apply. The instance group itself was already up, and some things to pay attention to here. This template, test DEL MIG, is now defined in this, in our instance templates. We're using this instance template here. And keep in mind, these didn't exist in this template repository before because they were literally created by Terraform. That's what Terraform does. It creates and destroys resources. You can see that I'm currently using the 3rd image, which, again, we talked about here. This is the 3rd image. This is the one which has the richest history of dependencies. Okay. And the nice thing is it's telling you that this is sort of in use by this particular resource. So let's test this auto healing capability. I can tell you, I've done this a couple of times. It takes a variable amount of time to sort of see what happens here. So we're gonna SSH into this machine. We'll take a look and see sort of what's here. And then we'll kill this machine. We'll destroy it, and we'll sort of see how long it takes this managed instance group to bring this single machine back up. In my testing, this took anywhere from about 5 to 12 minutes. So while this is healing itself, we'll test what's going on here. So just to show you that this has some of the resources that I suggested, let's see if what apt-get has to do. Oh, I think I have to be in sudo here. And, we're going through, we're fetching all these packages, and we'll see, these are all fetched, that, they're actually, I don't think anything's going to get installed here unless something changed in the last. Yeah. So we have all these packages already. I installed Python on here because that, is one of the resources that data engineers care about, getting into this Python shell. This machine, I can do basically whatever I want with this machine. It's a regular machine. So let's install a new package here. Let's see. All right. And we're installing Nginx. This is going to be a moderate, set of installations here. But let's take a moment for this to install, and now let's kill this machine. Okay. So in order to kill this machine, I'm going to use this gcloud code. I could probably also run this from my gcloud console. I'm going to run it here. Back in the right spot. Okay. So I'm going to run this gcloud command to kill this machine, and we'll see this deployment get pretty unhappy for a little while. Oops, I'm too far. So we're going to stop. Our instance name is test. Oops. DL, MIG, and then I've got this 0 LRM string of characters, and this is in the US Central B zone, Central 1 zone. So what we're doing again is we're testing the auto healing capabilities of this managed instance group. Yep. So what I'm expecting to happen here is this SSH window is going to tell me that, this machine can no longer be accessed because I submitted this gcloud command to shut this machine down. And once that happens, we will be seeing some of the statuses here change. We'll go into that in a moment. So let's see, it's 12:24. So I'm expecting somewhere around 9:40 at the latest, we'll see this sort of repaired machine come back up. So let's see the impact. When we stopped this machine, we're expecting to see a change to this machine status, which we do. It's being provisioned and will soon begin running. That's because my auto healing check is going to detect that this machine is down. So in my instance group itself, we'll also see there's a timeout associated with this other machine just because I hadn't finished configuring it, but the health check on the machine that I stopped is giving us a different status than the other machine. So let's take a moment, because this is going to take a while to spin itself back up. And let's discuss some of the other things that happened with this experiment, with this demo. So I mentioned earlier that when I ran Terraform init initially, I got an error. And that's something that might happen to you as well. So I wanted to spend a moment and discuss that. So when you run Terraform init, what it's doing is it's comparing the backend that you had defined previously to the current backend. So one of the things that I discovered when I did this is this DEL, or excuse me, the previous DEL that I did cost me about $3 to run. And part of that was because I left some of my machines on over the weekend. So like I did this DEL, I was working on it, I left some of these machines on. And when I finished with the DEL, I went and I essentially tried to destroy all of the resources that I had created. And that initially included I destroyed this backend bucket. And so when I went to run my Terraform init, when I picked this project up for the next version, Terraform said, all right, I'm going to go look at what the last Terraform state file was. And that last Terraform state file was stored in this bucket. And when it wasn't there, when it couldn't even find this bucket, it gave me this error. And, it was a nice verbose error, which basically told me what needed to go. So I went and recreated this bucket and ran another Terraform init. And now that even though the Terraform files were not there because this bucket had been deleted, the fact that it could find the bucket let Terraform initialize and put a new state file into that bucket. Then, because I wasn't especially interested in, having a remote backend on this, you'll see one of the changes that I made between the last DEL and this one is I changed my backend to local, which very simple. I essentially commented out the remote backend definition, and I just added this local backend, which means that my Terraform state files are going to be located in this Terraform working directory. And here they are. Okay. But that process of sort of cleaning up your resources, one of the things I would recommend, one of the lessons that I learned here is unless you intend to never return to the project, right? Leave the backend there. A Google bucket does not cost a lot. The things that got me up to $3 on this were the VMs running, and there's a very small fee associated with the machine images or with images and machine images. But really it's just if your VMs are up. So, this time I'm going to practice what I preach. At the end of this demo, you're going to see me shut down all these machines. Okay, so let's go on to the next piece, which I wanted to discuss here, because I strongly suspect that we're still going to be seeing these resources in process. It looks like the self-healing is done. It restored itself very quickly this time. So this was on the faster end of the restoration. I did notice sometimes my sort of SSH here would take a little while to restore itself. But I'm going to be interested to see. Python is for sure still going to be available here, but I'm going to be curious to see whether Nginx is part of this deployment, right? Because Nginx was not on the image that this template got deployed from, right? Nginx was installed after this installation process. So Python, still available, no problem. Let's look to see if it also restored Nginx. Not there. Oh, wait, no, let's try again. Let's put my sudo in there. So it looks like I will, like, what it did is it restored the original image. So this is leading us into the next piece of this demo, which is what literally is the process for updating the image that you want to use on your in your managed instance group. So yeah, none of these got installed. But let's not do this again here. And we can sort of talk about this process. So, all right. Actually, let's try that. I wasn't planning to do that, but I think this will be an interesting demo as well. So let's install it here. And what we're going to try to do is we're going to try to now create an image based on this particular machine. Very possible, no reason we shouldn't be able to do it, right? It's just another VM. But what you're going to see is here the reason why I recommended sort of having an additional machine that you use to build your images. So let's create an image here. And I'm going to use this as my source disk, and then I'm going to get this error message, which is what I was expecting. So they really want us to create an image from a stopped instance. And we could try to overrule that, but they're warning us this may create a corrupted image. The other reason that I want to have this separate image for development is I literally can't stop this image and keep it stopped, right? We saw, I ran that stop command, excuse me. I ran that stop command on this Google instance group and it restored itself. Where's my list of VMs here? Let's just go back to my list of VMs. Yeah, so this is already back up and running. It was less than 5 minutes there to get this VM back up and running. So I can't consistently use one of the machines in my instance group as the source of my VMs. So let's start this machine back up. This is sort of my image machine, sort of how I've been thinking about it. And then we'll SSH into here. Don't actually need that up anymore. So let's check out this machine. There's not a lot going on with it. I essentially just chose a relatively cheap machine type. And let's SSH into here and install our next dependency. So, sorry, let's take a moment here. Machine just came up. All right, so whoops. There we go. So, this set of things installs. Okay. I'm now going to stop this machine. That's funny because I hit back, it's not actually showing me the newest status for this machine. So I'm now going to stop this machine. I'm going to go to images and I'm going to create an additional image here. What was my naming convention? It was DL2 image test 4. Go. And it says I can pick from these, but recall if I'd picked from one of these, it wouldn't work. So it says this is running, but I guess maybe I just didn't wait long enough for it to shut down. There we go. So my instance stopped. I'm going to refresh this and try this again. All right. So here I get this new image that's getting created. And now we'll talk about how to update these machines that are running. I have this new image that's getting built. We're going to see that it's a little bigger than this 871 megs once it finishes building here. And now we're going to show two different ways that I can update this new image. So the first is through GCP. GCP's console essentially allows me to do virtually everything that I need to do. So here this particular screen is accessed by going into instance groups, clicking on the specific instance group that you care about. And now I'm going to update my VMs. So if you're curious, there are some details in this, which I'm going to publish along with the blog about the specific things that you can do to update your managed instance groups. There are a couple options that we'll dive into a little deeper here. The first thing is, that I need to pick a particular image template here. So what we'll see is the image itself isn't enough to update, right? We have to actually update this template, and you can create a template through Google, right? Through this console, no problem. I have these two templates that exist. That's what just showed here, right? I can only pick from these two templates. And if you recall, these templates are defined by Terraform. These templates are defined by Terraform. So this is the first template, okay? And this is the second template. Let's see, I think, yeah. So here's the name. This one is MIG2. If you look, this is the one which is, I believe this is the one that's currently in use. So, yeah, no, actually, this is the one that's currently in use. Test DEL MIG. So the reason that I had two here is because I'm going to sort of treat this as like a blue-green deployment. And this is sort of going to be a blue-green update. We know that there are things that are working in test DEL MIG, right? And I'm going to update this resource, this MIG2 resource, so that it's now going to get the newer image, right? DEL2 image test 4. This is the newer image. And because this resource is defined in Terraform, I'm updating it in Terraform. And now let's take a Terraform plan over here and see what happens. Okay. All I've done is change this single number, my Terraform code. So in my Terraform plan, what I'm expecting to happen, so I'm expecting one resource to change. And what it's telling me here is that it's going to that this is going to get replaced, right? Essentially, I'm going to be replacing the old version of this template. Again, this template is the one that's defined here. You can see the names match. This is template 2. And this is template 2. Excuse me, template 2. And this is the change that's happening. And that's a great thing about Terraform, is it's quite verbose about telling you what's going to be changed. All right, so let's apply this change. And this is going to take a moment. It's going to be destroying this, and we can sort of watch this happen. It's going to happen relatively quickly up here. I should be in instance templates. Let's refresh this. And you'll be able to see, this will probably be pretty quick, so this is not a resource heavy change, that this image changed from image test 2 to image test 4. And that's absolutely what we expected. So back to this update, okay? If I switch here, that's interesting. I think I'm going to have to update this as well, because it was still showing that template 2 was showing the wrong image, and now it's showing image 4. So I'm switching to image 4 here, and there are quite a few options that you can pick for this. So one of the main things that's happening here is a selective versus an automatic update. Okay, if this was a deployment, if this was a production deployment, I would almost certainly be choosing a selective deployment, which would essentially mean it's only going to change this image at a time that's convenient for the VMs, when the VM's getting replaced, refreshed, or restarted, or and not during auto healing. So this essentially says, all right, don't interrupt operations to update this VM. But because this is a demo and I want this to happen right away, I'm going to do this automatic. You have quite a few options for what's going to happen, what you can do here. Okay, and the thing that is going to be different between these guys, between refresh and restart and replace. Okay, I'm going to pick replace here. And the reason I'm going to do that is just because I want to show you what's going to change. And one of the things that's going to change here, I guess I don't really need images at the moment. Let's go back up here. When I replace this, we're literally going to get a different VM, right? We're going to get 2 different VMs here. So we're going to see this 0 LRM and this 7 HX2. We're going to see these strings change. So we were here. We're going to only replace. And, I could keep these same instance names. This would be another valuable thing for a deployment method, but I just sort of want to show you what's happening. We have this option for temporary additional instances. What this does is it says when this update is happening, add these new instances so that we don't end up with extra latency when these instances are getting deployed. And I think this is a pretty valuable thing that Google does. I actually can't lower this number because you cannot be lower than the number of zones in your group. And I'm in US Central, so my minimum number is 3 here. And this is a little bit silly. Maximum unavailable instances. This is just another sort of protection here. This says don't kill all my instances at the same time. This says don't shut down more than 3 instances at the same time to do this replacement, so that, again, we're not going to lose our ability to continue to provide service to our customers. Cool. So I've hit done, and now I'm going to update my VMs. And actually, I think I need to pull this side by side because this happened super quickly last time. So let's pull this side by side temporarily and see what happens here. So here I am. I'm looking at OLRM and 7HX2. And this image update, I'm really expecting to see this happen pretty quickly. That's interesting. So it says it's still updating here. So take in just a moment. Let's see what happens. Still going. So while this is updating, I just wanted to share some of the interesting other things that I found. We'll show this next step here where we update the image in Terraform as well. It's super simple. But we talked about a blue-green deployment. That's sort of what we're using here, where we're just switching back and forth between two deployments. So like blue and green, one's not inherently better than the other. This is just, I have a stable blue deployment, I'm calling it blue. And when I need to make a change, I'm going to spin up another deployment. I'm going to apply and test those changes in green. And then I'm going to switch my routing from going to blue, which is known good, over to green. That's a pretty useful deployment pattern for updates. And, just a pattern to think about when you have a system which is undergoing constant change, because all of us live in a world where, no software is done. Software is never done. There are always changes that need to be applied. We can also talk about the canary deployment, which is another method that you can implement for this, which is sort of moving only a small amount of your resources into the updated code. This is the canary in the coal mine example, where there's a really small piece of your customer base which is using the updated code. And managed instance groups have some great resources for those type of deployments as well, for those type of deployment tests as well. If you end up with that canary group not working well, that tells you, okay, let's switch all of our traffic back to the pre-update code and figure out what the heck is wrong with the canary code. We also discussed already automatic and selective. I picked an automatic one because I wanted it to happen quickly, but in production, you likely want to pick a selective code, or a selective update, so that you're gonna have your infrastructure experience the minimum amount of changes here. All right, so let's see. We no longer have spinning, and our machines now changed name. We no longer have the two names that we originally had, 0 LRM, and our HX2, like those are gone. We have literally new machines up here. And that was sort of an option that we picked. You can definitely do this without changing these names. That could be important. That would be important for dependencies. If you have resources that are pointing to these Google VMs. So we just did this canary update in we just did this blue-green update through Google's console, but it's really quite simple to do this through Terraform as well. So taking a look at our Terraform code, you can really come here and see, this is one of the reasons why I had two templates here, okay, two instance templates here, that this right here is defining the image, right? But the image itself is not defined in at least my particular instance group manager, right? The thing that's defined is the template itself, okay? So I right now am pointing towards this DL test MIG code right here, which we're now in an interesting situation with Terraform, where what the Terraform code is pointing to is actually different than the particular than the orientation on the deployment itself, right? Because the Terraform code says we're pointing at test DL MIG, right? But when we come and look at the actual deployment, my template is MIG2. So let's see what happens when I run another Terraform apply. And I'm not gonna auto approve this one because I want to see what changes. Oops. So I ran this Terraform apply, and let's see what it says. It says I'm going to have one to change here. Okay. And the thing that it says it's going to change is what we expected, right? Our instance group manager is pointing to something different in the actual GCP deployment versus in the code. And so what it says it's going to do is it's going to, in this case, it's going to change where the machine is pointing. I'm sorry. So this is going to undo the change that just happened. I'm going to go from the GCP project, which says I'm in MIG2, to the Terraform code, which says let's go back to MIG1. So let's do this. Let's see if this change gets applied in the project. So this is going to take a moment, but not a super long time, I would expect. So, oh, that's cool. I hadn't actually caught it at this particular moment. While it's doing this update, I think I'm ending up with this sort of surge here. So let's refresh this. Oh, that's interesting. I did end up with 2 extra nodes here. I'm not totally sure what's going on with that. But let's come look at my VM instances and see if this is a temporary state of affairs. I suspect these are in the process of getting stopped. Yep, these are being stopped. So what it did is it took these instances, which I previously had, which were associated with the template number 2, and it moved these guys back to this template number 1. Cool. So it basically said the Terraform state file does not match the deployment. And because I ran Terraform apply without running an update state, it said, all right, let's make the Terraform file. Let's make the deployment match the Terraform state file. So I said it was going to be really simple to change this. And it really is. If I want to use the new image that has Nginx installed, literally all I have to do is change this instance name. That's it, right? Now what this is doing is now the Terraform state file is going to point to this new instance. Let's make sure these are done. I'm sure it would be fine, but I'm just curious to see if this is done. Yep. Whoa, wrong one. So let's go back to my VMs. Yeah, so it finished killing those other 2 VMs. And now I've got these new ones here. And if I run another Terraform plan, it's going to show me that I'm going to end up with these resources getting destroyed and the new image getting used. So this is sort of the process for how can you use these resources, this Google Managed Instance Group, these images, these instance templates, to actually do a process of developing and deploying new code onto your system. So wow, I didn't pause to ask for questions once. Akwi, are there any questions in the chat?
Yeah, that's okay. We haven't had any questions come in.
All right. So just going to share some of the resources that I thought were useful here. These were some of the original resources from the original DEL, if you're trying to follow along. And then I found especially useful this 3rd resource here, which I'll even show you, about applying VM configuration updates in an MIG. This is where it will talk to you sort of about what your different options are for opportunistic or proactive, what they mean. And one cool thing is most of these resources, most of these properties can be applied in the in Terraform as well, right? So you can specify what the max unavailable property should be in your Terraform code, so that when you do this up, you can specify the replace name, right, in your Terraform code, so that you don't constantly end up with new names if that's something that you want to do. All right, Akwi, I think I'm done. Thank you guys so much for being here, and I'm happy to take any questions at this point.
Thanks, Nick. And like Nick mentioned, while we wrap up here, if you have any questions, go ahead and drop them in the chat. I'll go ahead and relay them while we close out. Just a couple housekeeping items before we close out for today. Do remember that our latest runbook is available. That's available. The link is available in the chat as well. Also available on our site, anant.us/runbook. Also, if you haven't already, please like this video and also subscribe to our channel so you get notifications whenever we go live. I'd like to thank everyone. Thanks, David. I'd like to thank everyone for joining us. We'll see you guys same time, same place next week. And have a great week. Take care, everybody.
Bye, everybody. Thank you.